Hello everyone. In this video, I will just talk about this revision slide, which is based on our linear function and quadratic function. This is the review kind of review of these two sections. So this is review. There are reasons for this review actually, and the reason is say you know that your quiz one is coming up, and quiz one is actually on this two topic, which is linear function and the quadratic function. So a quick review from the linear part first, and this is, as you can see here, this one ax plus by plus c. This is called actually the standard form. Y equal to mx plus b. This is called the slope intercept form, and point slope form is y minus y1 equals to m into x minus x1. Why they have this different name? There are reasons. Why it is slope intercept form? The reason is here b is the slope, b is the y-intercept, and m is the slope. I mean, very easily in this form, from this form, very easily you will know which one is slope and which one is y-intercept. That's why this is called slope intercept. And why this is called point slope form? From this form, very easily you will know what is the point and what is the slope. What is the point and what is the slope? Very easily you will know that. How you will know it? You will know it because m is the slope and y1, x1, x1, y1, you can say x1, y1. This is the point. That's why it is called the point slope form. Now, why it is useful? Why it is useful? In any math, if we give you, or if anyone give you a value of one point and one slope, then you have to use this equation to find out the equation of a straight line. If anyone give you in this question, like this question, if anyone give you slope and y-intercept, then you will use this equation to find out the final answer. You use this, you can say this is definitely equation, but you can say formula also, or format. This is not exactly formula, uh, but we can say this is a good shape, or dice, we can say dice, format. And this is a standard form because we have all the components of a straight line here in a very nice and regular way, kind of that. That's why ABC is integer and x and y. The value of the exponent of x and y is 1 1. That's why. So these are usual to. These are good to actually know all of them. Domain of real number is all real number, and range is also all real number, but in some cases there are some particular cases where it may vary, very very uh, extreme cases. In very extreme cases they can vary. For example, if you talk about the horizontal line and perpendicular line, then the domain and range is not all real numbers. uh, or else when the restriction is given, then it is not all real numbers. So this is the basic discussion of from the linear function. To special type of linear function or line, straight line, is horizontal line and vertical line. They are very special kind of. Why they are very special? Because in terms of domain and range also they are special. Or even if you look at like slope of a horizontal line is 0, slope of perpendicular line is undefined. And why it is 0? The reason is, you see, change in y is 0. Change in y is 0 means what? 0 means what? This line is where? This line is at -2. Eh? and 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 where it is going? Is it going to the -3 or +1 +2? Is it going up or down? It's not going up or down. This line is not going up or down. This line is fixed. So that means there is no rise. There is no rise. It is not going up or going down. There is no movement in the up and down direction. But in the left and right direction, the line is moving. So change in x we have some value, but change in y we do not have any value. That's why change in y there is no value. That's why it is 0. 0 divided by anything equal to 0. That's why the slope of any horizontal line is 0. And why the slope of the vertical line is undefined? The reason is here change in x is 0. See, the line is not, the line is going up and down. Up and down means y value. Y value. We have some y value. And that's why change in y, we have something, anything here, change in y, up and down we have. But in the left and right, the line is not moving. Yeah, there is no movement of the line in the left and right. Yeah, there is no. Suppose in another way we can say it is there is no x value change in the in the in the vertical line. Yeah. Any point. Suppose what is this point? What is the value of this point? This value of this. What is the value of this point? 1, 2, 3. So this is 3 comma 0. What is the value of this point? 3 comma 1. What is the value of this point? 3 comma 2. So see that 3 is fixed. This is the x value. X value is fixed. X value is not changing. That's why x value is not changing. See, this is not changing. This is fixed. Now you can say, sir, why you are not putting here 3? The reason is this value will be change. Change means 3 minus 3. This value to this value. Suppose this value to this value. 3 minus 3. Answer is 0. Even this value to this value also you can write. This is also 3, as you know, because of the vertical line. So for vertical line, long story short, the vertical line is change in x. There is no change in x. That's right. For parallel line, this line and this line, these two lines are parallel. For parallel line, always you will see their slope will be same. If this lines, suppose if this line's slope is, let's say, suppose minus 0.5 something, anything, whatever the slope of this line is, this line's slope will be exactly same because they are parallel. For parallel line, their slope is same. Other value is different. For parallel line, their slope is same. Other value is different. For perpendicular line, so you see this line is perpendicular to both of this line, or you can say both of these lines are perpendicular to this line. That is also true. Okay, that is also true. And if this line and this line is perpendicular, what will be the relationship of their slope? Let me write. So the slope, suppose this line's slope is, let's say this line's slope is, let me give some number. Let me give some alphabet so that you are not. So suppose this line's slope is minus a. This line's slope is minus a, suppose. So what will be the slope of this line? This will be 1 divided by a, like that. And let me make it easy, because minus a, 1 divided by a, what does it mean? Suppose one line's slope is 2. One line's slope is 2. Now if I ask what will be the another line's slope which is parallel to this line, answer will be simple. Answer will be 2. Parallel means same slope. Now perpendicular, if I say what will be the perpendicular line's slope of this line which has slope 2, answer will be 1 divided by minus 2 or minus 1 by 2. There will be a minus will come. Negative reciprocal. This is why it is called negative reciprocal. See the word negative reciprocal. Negative reciprocal means this. Now if in my question, if I directly give that this is minus 4, suppose one line's slope is minus 4, what will be the slope of the perpendicular line of this line which have slope minus 4? Answer will be 1 by 4, because already we have a minus here. So now that minus will be eliminated from here. So that's the relationship between parallel lines and perpendicular lines. These are useful when we want you to find out the equation of another parallel line or another perpendicular line of some lines. Then this concept is useful. This is called finding models for linear data. Finding models for linear data. So you see, this is a scatter diagram, scatter plotting. The rule is we have to find out like some more or less based estimate, as better as possible. We have to find out some estimate so that it works for for some prediction and other purposes and other uses. How do we draw this line? We the rule is we have to find out some like um, uh, this line has to follow the trend of the data, and also there should be equal number of points up and down, or more, or approximately equal number of points up and down. This is like you can say, sir, how many points are there? Count it. In some cases, like suppose in some extreme situation, if you cannot count it, then you should at least go for approximate, like more or less same. Suppose here you have, let's say, very big data, very big graph in real life somewhere. eh, Suppose here you have 200 points, here you have 197 points. This is okay, all right, this is okay for your drawing. But if suppose there is only 10 points, 5 points, 8 points, then you should actually try to make it as best as possible. So you see, our all the data is within these two lines. Suppose all the data is within these two lines. That's why this red line has to be somewhat in between the this purple. I think this is this purple color. Is it purple color? Okay, this is I assume this is purple. So in between this in in between this line. Okay, now why I'm drawing this line and this line? The reason is, someone can draw a line like this. Someone can say, sir, I draw the line like this, and the equal number, same number of points this side and that side. So is it my best fit line? That's not correct. That's not possible even at all. Okay, that's not possible even at all. We have to follow the data. All the data is within this box. So your mid, this your base fit line should go through the more or less through the middle. Okay, more or less through the middle. There are many other concepts actually related to it, to make it better and better and better base fit line. There are many interesting other things also, but just for our purpose, make it like this. Make it like this. Next work is like drawing. This is one mark. Then we have some more marks here for other purpose. So and no worries, like don't think like if your drawing is little bit different, if my drawing is little bit different, then what about the marks? Actually we have some tolerance here. We have some, suppose let's say we have got slope 0.71. Now your slope came 0. Let's say 69, or 0.78 or 0.75. Usually it comes very same. Do you understand? Usually it comes very close. So we accept it. Do you understand? We accept it. So don't worry about that. Now, how to find out this? Suppose your straight line is found. Now, how to find out the slope? And then how to find out this equation of line? So the process is simple. You choose some points on the line. Say, suppose we have chosen this point and probably this point, I assume 90%, 88, 90, 88, 98. So 88, 98. No, not this point. Some earlier point here, like here, somewhat here, some points here. So these 2 points is chosen. Now you can choose any points. Like, do not choose like this point. Do not choose this point. You have to choose any points from the line. Suppose this is not. You have to choose some best points from the line. You can choose other points, like any other points. Any other points will work. Suppose randomly this point and this point also. But when you choose, what I'm looking for, like this and this, is I'm just looking for some good point. Suppose a good point, not for this graph. Suppose good point means if I have a line, good point means this kind of point when the point is at the corner, and also on the line. This is called a good point, because this is good point for many reasons, because this is very easy to estimate for you to do the calculation. Anyway, so you choose 2 points, any 2 points from the line, on the line. You have to be very careful about this. And you can choose directly the points, like this point also you can choose. Suppose this point is directly on the line, so you can choose this point also, no problem. But the point has to be on the line. That's the point. Then from the 2 points, you can find out the 2 point slope when you have 2 points. When you have the 2 points, you can find out the equation also. Just put the value of the 2 points in the slope, in the point slope form, and find the slope. Then you get the equation actually. When you have 2 points, then actually other things is just calculation. Rules is same everywhere. Actually, in the homework also you have solved how to find out the equation of a line when 2 points are given. Same rules is same everywhere. When you have, so you see that technique is what? Technique is main purpose is to find out that 2 points on the line. That's why you are drawing the best fit. Yeah. When you have that 2 points, when you have that line, actually you can do the other things if the question extends. This is quadratic function, review from the quadratic function. So this is the standard form ax square plus bx plus c. This is the standard form of the quadratic function. And for any quadratic graph, quadratic function, domain is what? Domain is all real number. Because the line will go this way forever, this way also forever. And if it is down opening parabola, same will happen for the down opening parabola. And for the down opening parabola also, it happens the same. The line will go forever in the both direction. The line will go forever in the positive and negative both direction. And this is our vertex. This is our y-intercept. This one is x-intercept. But range is not all real number, because you see this is the lowest value. This value is the lowest. After below this line there is no graph. The graph is above this line, so the range is not all real number. In this question, range is from -4 to plus infinity, plus positive side plus infinity. So this is how we get the range. Graphing. So when the vertex form, when you have like a into x minus h plus k, this is the vertex form of our this is the vertex form of our parabola. When you have the vertex form, so how do we draw it? So one example is directly given here. You know this is the vertex form, and like some questions are usually given like this. This is the value of h, this is the value of k. So we know that this will be the vertex, this 1 comma minus 3, this will be the vertex. And if it is plus, this value will be minus, because of the formula is minus. There is a minus already in the formula. So minus, what minus actually does in the math, always remember, minus actually changes all the sign after it. If there is a minus, after that minus you multiply. Suppose there is minus bracket, then within the bracket all sign will alter. If there is a plus, it will become minus. If there is a minus, it will become plus. This is what minus does. Okay, there is a minus, then bracket, then within the bracket you have a lot of other things. That minus before the, like this minus which is before the bracket, what it will do? It will change all the sign after that bracket. Within this bracket, it will change all the sign. So same thing is happening here. So same thing is happening here. This is minus this will become minus, and then 3. So this is the vertex. So vertex is here. This is minus 1 comma 3. This is minus 1c, and this is plus 3. So this is minus 1 comma 3. This is minus 1 comma 3, and then what about this minus 0.5? What about this minus 0.5? Minus 0.5 comes from here. See, if you go 1 unit this direction, then you go half in the other direction. Okay. All right. So this is 1, and this is 1 half, like 1 divided by 2, kind of. That half means divided by 2. That's why it is half, minus half, and minus because minus divided by, minus because this is down opening parabola. This is another reason why it is minus. Even you can do it in this direction also. This is one side 1, and this is the half of 1. This is not the 1. This is half of 1. 1 by 2, half 0.5. So this is like, and minus comes from the down opening parabola. Other things like x-intercept, how do we get the x-intercept, how do we get the other y-intercept? Y-intercept actually from this graph directly it comes. And other value actually, if you extend it, then we can actually find out this value also from more extended version. Like to get the x-intercept, we put y equal to 0. When you get this, and to get the y-intercept, we put x equals to 0. We put x equals to 0, and see, if we put x equals to 0, we can actually have this also. If we put x equals to 0, it becomes what? 1 square. 1 square means 1. 1 means minus 0.5. That means minus 0.5 plus 3. That means 3 minus 0.5 equals to minus plus 2.5. This is plus 2.5 actually, this value. So we actually get this x-intercept and y-intercept, and their rules is same. Their rules is same. Rules always remain the same in mathematics. That's the beauty of mathematics. Rules always remains the same for all the math. For all the math, they always remain the same. Do not think like, oh sir, you said to get the x-intercept, I put y equal to 0 in the linear function, but this is quadratic. In the quadratic also, to get the x-intercept, you put y equal to 0. To get the y-intercept, you put x equal to 0 in the equation. So this is the equation, this is the function. It must work, and it will work. Okay, so if any, not all, only here, anywhere in mathematics, anywhere, if you get this function, if you get the equation, it will always work. Factoring quadratic function and to find out the x-intercept. This is actually a middle term math, like x square minus twice x minus 8. So if we want to find out the x-intercept, we have to factor it. So the process of factoring is written here actually. If we factor it, we get x plus 2 and x minus 4. So one real 0 is minus 2. As you know, if there is plus 2, then minus 2 is the real 0. X minus real 0 means x-intercept. If this is x minus 4, so answer is actually plus 4. Then that is the x-intercept. This is the middle term factoring. We call it middle term factoring, or there are sometimes you can factor it by taking common. Sometimes you can factor it by grouping. Sometimes you can factor it by this is middle term factoring kind of process. So there are many ways to factor. Factor means like something into something. In this case, it is x plus 2 into x minus 4. So this is the factor. Now see, this math, there are two kinds of math. There will be two kinds of math. One type of math you can factor, one type of math you cannot factor. Because especially if there is some decimal value here, or some odd value here, different types of awkward values we can give in the, like instead of 2. Suppose if I give like some crazy value, let's say minus 27. Let's say if I give here 27, some crazy value, different value, then you will see that it is not possible to factor. Then we have to use this quadratic formula if factoring is not possible. Of course, you can use this quadratic formula there also, but in particular, if factoring is not possible, then we use this quadratic formula. And example is this: b minus b plus minus b square minus 4ac divided by twice a, and abc. This is a, this is b, this is c. The value of x square is a. X square is not a. The value of x square is a. The value of x is b. The value of this constant term is c. Value means this is misleading. Coefficient, I should say coefficient, not value. Or I can say that the value with x square is called a. I should say it this way. Or very straightforward is coefficient of x square is a, coefficient of x is b, and the constant term is c. And then you put it here, just do some calculation, simple calculation, you will get the two values. Sometimes you may get one value, sometimes you may get no value, especially if there is some negative value within the square root, then of that math, there will be no real 0, which is said here. This is the summary from all the discussions about the quadratic functions. This is the standard form, vertex form, intercept form. From the intercept form, why it is called intercept form? Because from this version we can easily directly get the intercept. P and Q, they are the intercept. Why it is called vertex form? Because if the equation is in this form, then we can directly know what is the vertex. What is the vertex? Yes. In the standard form, Actually, most of the maths is given in the standard form most of the time, not always, of course. From the standard form, we can find out the vertex, we can find out the x-intercept by following this process or procedure, etc., etc. And everywhere, what A does is opens the value of the coefficient of A. Coefficient of A is not A. The sign of A, actually, let's say this is the sign of A tells us is it open up or open down parabola, and other thing also it says hmm, like we know it in this two ways. So if the like if A is positive, if the value of A is positive, suppose this is positive 2, that means open up. If it is negative 2, then it is open down. If it is instead of 2 it is 8, that means the graph will be more narrow. Eh, if it is decimal, suppose A value is 0.2, 0.1, 0.25, then the graph will be wide. So this kind of thing. Actually, all the thing here that you see, they have some different role. They play a different role in the function. If you change them a little bit, this to that, then actually the change of the shape, the shape of the graph changes. Okay. So I have this. We have this kind of thing, and I think just to save the time, we'll make another video for this. So up to here is our this video, because this is the basic discussion, and the next part is uh, directly related to the quiz. Okay, so I think I should do it. Like, stop share maybe. Okay.